CQ the X, CQ the X, CQ the X. This is Havana calling. CQ the X, CQ the X, CQ the X. This is Radio Havana calling all shortwave listeners and radio amateurs. Welcome to... DXers Unlimited, Radio Havana's weekly feature dedicated to the fascinating world of radio communications.
Hi, mis amigos radio aficionados all around the world and in space. Yes, my friends, your receiver is now tuned to the shortwave frequency where you are just starting to listen to the weekend edition of DXers Unlimited, the radio hobby program that provides you with the most up-to-date, accurate, and reliable shortwave propagation updates and forecasts. And the news is that sunspot numbers and solar flux made a strong comeback between March 30 to April the 5th. And then the sun went once again into the slow speed mode it is now going through. Between March 30 and April 5, the average daily solar flux was 96.5, and this compares to 77.9 the previous 7 days, and just 71.2 of the week before. That was between March 16 and the 22. Average daily sunspot numbers progressed at a fast pace from 3.4, then to 29.7, then to 65.9 over the same 3 weeks, and is now going down again. The latest daily forecast for planetary A index and solar flux shows a downturn to solar flux of 76 on April the 7th, estimated to be 70 between April 8th and the 13th. And now our next radio propagation-related item. Ionospheric propagation researchers all around the world will carefully watch the upcoming sporadic season of the Northern Hemisphere in order to try to validate the criteria that sporadic events do happen more frequently during the solar minimum activity years, the ones we're going through right now. Hams that operate on the 50 MHz or 6 meters band will certainly enjoy the best openings of the summer skip season, due to start, as usual, at the very late April or early May. Some of those openings extending from North America and even on very special days from the Caribbean all the way to Western Europe and Northern Africa. Please stay tuned. I'll be back in just a few seconds with more Radio Hub-related information after a break for Station ID. I'm Manny Coro, Radio Amateur CO2KK, your host in sunny, beautiful Havana, Cuba. You're listening to Radio Havana Cuba. The name of the show is DXers Unlimited. Here is now Item 2, the technical topics section of the program. Today we'll be telling more about the ultra-simple ham radio equipment that some radio hobby enthusiasts around the world are building and operating with quite successful results. One excellent example is the growing interest generated around the world about new solid-state versions of the world-famous Para set, a World War II very simple transmitter-receiver combination built by the British for providing behind-the-enemy lines clandestine radio operators with a compact unit. During the Second World War, the only active electronic devices available were vacuum tubes, so the designers of the Para sets had no other choice but to use them. The rig consists of a tetrode vacuum tube operating as a crystal-controlled oscillator and capable of putting out no more than 5 watts of radio frequency power into a makeshift stealth antenna. Or by definition, the original Paraset, we may say, is a QRP, or low-power transmitter. The receiver used 2 pentode tubes, or valves, as the British call them, one acting as a regenerative detector stage, and the other one as a high-gain audio amplifier, feeding headphones. In actual practice, due to what may be considered a design flaw, operators using the Parasets ran a very high risk because their regenerative receivers radiated a signal that was then put on the air by the antenna all the time. So they, so to speak, were on the air all the time with the Paraset when they had it in operation, both when receiving and when transmitting. By the way, the big mistake, in my opinion, by the designers of the two-way shortwave communication set was not to include a simple radio frequency amplifier stage ahead of the regenerative detector in order to prevent signal radiation into the antenna. The original Paraset design made possible that the highly skilled and very well-trained German Army radio direction finding units were able to pinpoint the location of those sets while it were receiving and do it with deadly precision. One great disadvantage of the paraset receiver, only second to the fact that it radiated a signal into the antenna all the time, was that tuning the receiver was very difficult to the operator due to the lack of a properly designed slow-motion band spread tuning mechanism. This is something that I could not understand, as it could have been easily solved by adding a small air variable capacitor trimmer in parallel with the main tuning capacitor, or a rather simple mechanical arrangement to slow down the movement of the receiver's main tuning capacitor. In the original paraset, the variable capacitor that tunes the regenerative receiver had no vernier reduction drive, and there is no second band spread dial. So finding the station that had to be received was at the other end of the communications link should have been quite a challenging task to the operators of those World War II sets. Anyway, more than 70 years after the first paraset transmitter receiver boxes were dropped over continental Europe during the war for the first time, those radios have won the attention of many 21st century radio hobbies worldwide, who are building exact replicas, and also they have designed and built a solid-state version with many upgrades that improve its performance in a very significant way. By the way, at a recent edition of DXers Unlimited, I asked the following question: are you ready to improve the performance of your shortwave radio receiver? And I also added that it could be done at a rather low cost with amazingly effective results. So here is yet another example, an actual practical example of how to improve a low-cost shortwave receiver's performance. You can homebrew my Pi network antenna tuner and signal attenuator all in one box and enjoy the dramatic improvement in reception quality that your newly built station accessory will provide to you. If built with high-quality parts like ceramic-insulated airspace variable capacitors and high Q factor coils, you will see that the results of many cases will prove to be simply amazing. A low-cost portable shortwave receiver of the present generation usually lacks adequate front-end selectivity. It's a cost-cutting way of doing it, and that is precisely what you add ahead of the radio by connecting your antenna tuner, my Pi network antenna tuner and signal attenuator, between the antenna and the receiver. Your radio will now have 4 additional controls to tweak for optimal reception: the signal attenuator at the antenna input, the 2 tuning capacitors of the Pi network, and one at the input and the other one at the output of the network, of the antenna tuner, and the multiple connection switch to select how many turns of the coil are needed for optimum reception. You can use a simple carbon track potentiometer for the signal attenuator, or go ahead and also build a more sophisticated step-by-step attenuator that may even be calibrated in a combination of 3 dB and 10 dB steps. Even rather expensive, up-to-date digital receivers that benefit from my signal attenuator and Pi network antenna tuner box when they were connected to it. The reason why it works so well is that my Pi network tuner tunes very sharply, in contrast with the present-day designers' cost-saving radio frequency input circuits that provide just bandpass feature without sharp tuning. Let me explain that in some detail. A modern solid-state receiver or amateur band transceivers no longer have an antenna picking trimmer control. You won't find it, because the input circuit that connects the antenna to the radio frequency amplifier stage of the receiver is untuned. Actually, it is designed to pass a certain band of frequencies with little attenuation. For example, when you select the 7 MHz or 40 meters band of a typical present-day amateur radio transceiver, the set switches in using a pair of relays, a bandpass filter that has a tuning range typically from 6 to 10 MHz, leaving the front end unprotected from the presence of mega-power international shortwave broadcasters operating above 7,200 kHz during the present days. By connecting Arnie Coro's signal attenuator and Pi network antenna tuner box between the antenna and your radio, the receiver will only see a very small bandwidth around the center frequency where you are operating, and that leads to much better reception by all means. And now, as always, at the end of the show, when I'm here in Havana, here is Arnie Coro's high-frequency propagation update and forecast. Solar activity has gone down dramatically. We're now back again to almost baseline level. Solar flux around 70, 72 units for the next several days, and that means poor propagation conditions on the higher frequency bands. See you all at the middle of the week program, Tuesday and Wednesday UTC days, just after the half-hour newscast, and send your signal reports and comments to info.rhc@enet.cu or via airmail. Send a postcard or letter to Arnie Coro, Radio Havana Cuba, Havana, Cuba.
And that's all for today. This is Arnie Coro, Radio Amateur CO2KK, your host here at Radio Havana's DXers Unlimited, saying 73 and very good DX.
DXers Unlimited heard every Sunday here on Radio Havana Cuba, also on Tuesdays, right here on RHC.